Okay, so we want to discuss log base 1, just because we're interested. Okay, so if we say log base 1 of x is y, then what does this mean in terms of exponents? Not quite.
1 to the y is equal to x.
This means 1 to the y is x, right? What's 1 to any power?
1.
1, right? So this means that 1 is x regardless of what y is.
So x is all real.
You guys see that? No, x can't be all real numbers. It has to be 1. It can't be anything else. You guys see this? So there's only one kind of content here, right? There's only one sort of specified x value, and it doesn't matter what the y is. You guys see that? This thing fails to be a function. Because it's a vertical line.
I see that.
You guys see that? So if I was to graph this thing, right, if I'm thinking f of x is log base 1 of x, the only content there is that x has to be 1. It can't be anything else.
So guys, I mean, that x to the power of whatever, or it would have to be x to the power of 0.
So this is the graph of that log base 1. It's just not. It's not a function. It is a vertical line. It fails the vertical line test miserably, right?
There's an infinite amount of
Because
lines going.
that one vertical line overlaps not only once, not only twice, which is the problem, but infinitely many times. The similar analogy to this one is so this is the log base 1 of x function. The other question you might ask about is the function y is 1 to the x, right? This should be the inverse of that function, right? You guys with me on that? This function, that function should undo each other. If I graph this one, what's 1 to the any power? 1, right? So the output of this for any x is y equals 1. You see that? So this is the function 1 to the x. If I flip over the line y equals x, right, my trick for finding inverse functions, or for finding graphs of inverse functions, see that they're actually related that way, right? But this one fails the horizontal line test. It doesn't have an inverse function, right? This thing that should be an inverse function, of course, fails the vertical line test, right? Because that thing didn't have an inverse function. You guys see this? These two are weird, right? These are kind of the reason your book often writes, and the base isn't 1. Because when the base is 1, the logarithm doesn't make any sense. The exponential function's really boring. Does that make sense? Like otherwise, the exponential function has some richness to it, you know? It looks like, normally those exponential functions look like this, or like this, right? You guys see that? But they kind of have this weird switch. When I go from the base is smaller than 1, which is the exponential decay, to the base is bigger than 1, that thinks something about immortal critters or radioactive things that don't decay, right? That's a bit weird. So we usually try to exclude that case because it acts funny. Cool.